Okay, let me start. Hi, my name is Jerry, and I work as AI research engineer at Upstage. I'm really glad to have a great opportunity to give a presentation about lag and Upstage products. I heard that you're some of the most brilliant students in the world and participants in the world. Okay, then let's get started. In today's presentation, I will talk about the basic concept of RAG and agents and how to build a Gen AI-based application using Upstage products. These are the concepts of today's presentation. First, I will explain the basic concept of RAG, Retriever Augmented Generation. Next, I will introduce our product, document parsing, which can be significantly useful when building a RAG pipeline. Third, I will talk about agents, which I believe is the hottest keyword in this field at the moment. And finally, I'd like to introduce another product from Upstage, Information Extract, which is now public open with beta. You can use this product to extract structured information from any type of unstructured documents. It can be especially useful when pre-processing documents for agents to understand or for communication between agents. I will cover more details in the later parts of the presentations. In this section, let's cover the concept of RAG, Retriever Augmented Generation. This slide shows an overview of the RAG pipeline. Basically, the core concept of RAG is to combine search results from the web or a database, which can be considered a source of truth, with LLM generation, to ensure that the generated answers are grounded in factual information. To use a retriever system, it is necessary to make document data searchable. This process typically involves two main steps: embeddings, which transform text into vector representations, and a vector database, which store these vectors and supports search functionality based on the similarity. In an inference scenario, a user asks a question about certain topic. The retriever search for the relevant data from the vector database based on the similarity between the user's query and the documents in your database. The retriever finds information related to the query. Finally, the LLM uses this retriever information to generate an answer grounded in those facts. In this way, you can reduce the hallucination problem, which has been a major challenge for engineers around the world working on Gen AI-based applications. So now, I hope all of you have a good understanding of what lag is. As I mentioned in the previous slide, technically, RAG consists of two parts, retriever and generation. There are many retriever strategies, and you might adopt one or more of them depending on your application requirements or the type of your data. In terms of generation, since recent LLMs can handle most NLP tasks, including question answering, summarization, classification, and so on, you can build various types of application while ensuring that the generated answers are grounded in factual information by using this lag framework. Let's take a look two generalized use cases of RAG. First, you can consider applying RAG to expand the knowledge of an LLM. Basically, knowledge is injected into LLMs during training time, but in the real-world scenario, it's very common for LLMs to be required to access up-to-date information. The second use case is concentrations of knowledge. Imagine you are building an app that can answer users' question about CUDA troubleshooting manual. Since there have been many versions of CUDA, and the answers may vary depending on the version of CUDA, it might be necessary to allow users to specify which version their question should be based on. So in this section, let me introduce our flagship product, Document Parse. This is the RAG pipeline I introduced in the first section. As you might have noticed, the most important element in this pipeline is the data. And it plays a key role in building a reliable RAG system. If the quality of data is poor or the structure of data is hard to understand, your system may end up generating incorrect answers. Therefore, pre-processing the data is one of the most important parts of building product-level RAG system. This slide shows an illustration comparing structured data and unstructured data. You can think of structured data as data with defined format, like a SQL table. On the other hand, any data that doesn't follow a fixed format can be considered unstructured data. Let me give you a simple quiz here. What % do you think is unstructured data in the enterprise side? Anyone who can answer this question, simple quiz? Okay, the answer is that 80% of data is unstructured. Enterprise data are mostly in document form. So how different are these two types of data? For structured data, it is easy to perform complex search using SQL. It's also easier to transform it into a structured format that LLM can understand and process effectively. On the other hand, unstructured data has a flexible format. However, when we pass this kind of data to LLM directly, it's more difficult to fully understand it. That's why pre-processing of unstructured data is a key factor in building an effective RAG system. Why is it challenging to properly read unstructured data like documents? The main reason is that these documents include not only plain text, but also visual elements such as tables, charts, figures, and headers and footers. For an LLM to fully understand the documents, these various visual components need to be accurately represented in text form before being fed into the LLM. So, Upstage Document Parse is a product that takes PDFs or images as input and converts them into semi-structured data in the form of HTML. By converting documents into HTML in this way, not only the original text, but also document elements like table, chart, and figures can be preserved. This makes it easier for search engine to retrieve and also help LLMs better understand the structural information within the documents. Now, I'd like to give you a brief demo using our console. You can experience it in the playground. Because of the time, I will skip the demo. Also, we have API documentation link. Feel free to refer to it throughout the hackathon. You can search with the keyword document parse in Google, and our product will be there. And this slide shows the difference between reading a document with Upstage document parse and simply extracting text with traditional OCR technologies. Let's say we have a document that includes a simple table structure, as shown on the left side of the slide. If you use OCR to read this document, the table structure will be lost, and only the raw text is extracted. On the other hand, when you use our document parse product, the table structure is preserving using HTML tags, allowing the documents to retain its original layout. Now, let's imagine that we build a RAG system using the preprocessed data from each method. When we fed the LLM with the result from document parse, where the structure of the retrieved data is well preserved, LLM can provide a proper answer to the user's questions. On the other hand, if we use data extracted by OCR, the LLM fails to interpret the information correctly because the table structure is missing. As you can see, pre-processing unstructured data is a key part of building successful RAG systems, and Upstage document parse is a powerful tool that can help you handle this process effectively. I hope you take an advantage of document parse during the hackathon to turn your idea into great products. In this section, let's see the concept of agent. An agent can be simply defined as a combination of LLM, a set of tools the LLM can use, and the orchestration logic that control how those tools are used by LLMs. As many of you may know from using ChatGPT, it uses not only an LLM, but also various tools like code execution, search, and calculator, depending on the user's request. You can think of this kind of application as a type of agent. Before we dive deeper into agent, let's take a review on the traditional language models. Just a few years ago, NLP researchers and engineers used to build separate models for each NLP task. For example, there were specific language models for summarization tasks, and also another separate models for classifications. And each model was designed to tackle a single task. But now, LLM is able to handle all of these tasks on its own by significantly increasing the size of language models and training them on large-scale data. We've ended up with models can understand user inputs and perform wide range of tasks. This ability to understand instructions and take the appropriate actions is called reasoning. You can think of this as one of the key characteristics that differentiated LLMs from traditional language models. So, what is agent? The core idea behind the agent concept is to let the LLM focus on what it does best, the reasoning, while outsourcing other capabilities like math calculations or search to traditional software that handle those tasks more effectively. These external services are referred to as tools, and in this system, the LLM focuses on reasoning about when and how to use each tool, depending on the situations. Here, the terms unstructured and structured comes up again. As I mentioned earlier, in order for the LLM to communicate with various API tools, it's essential to convert unstructured data like the one shown on the left into a structured format like on the right. Then LLM properly can call and interact with existing tools that are implemented in a traditional API format. I assume many of you have used feature like function calling provided by OpenAI. It's very useful capability in this kind of scenario. But what if the user input isn't a simple query like in the previous slide, and instead comes in the form of unstructured document like the one shown on the slide? In that case, extracting fully structured information from the document becomes a critical part of the agent system. Once this structured information is extracted from the user's documents, the system can then use it to call various tools and perform different tasks. Let's look at an example. On the left side of the slide, you can see a receipt from an animal hospital. If we extract data such as diagnosis, treatment cost, and treatment date from this document, we can then use that structured information to perform tasks like automated insurance claim review or report or summary generation, as shown on the right. If the document parse product I introduced earlier is a key building block for RAG, then the product I will introduce in the next section, named Information Extract, is the key building block for agentic systems, especially for the communication between agents and tools, or even between agents themselves. Let's dive into the information extract. Information extract is a product that allows you to extract structured data in any format from various types of documents. You can provide different types of inputs such as PDFs or images, and then define the structure of data you want to extract in the form of a JSON schema. I will show you an example on this in the next slides. Since creating a schema from scratch can often be a little bit tedious, our product also provides a feature that automatically generates a schema based on the user's documents, suggesting what kind of information might be worth to extract. Starting from the next slide, I will go through a step-by-step explanation of how to use it. The information extract demo consists of 5 steps. In the first step, you upload the document you want to extract information from. In step 2 and 3, you define the structure of data you want to extract in the form of a JSON schema. In step 4, the information extraction is performed. And finally, in the step 5, you try running the entire process in the form of an API call. The first step is document upload. As you can see on this slide, it's very easy to upload your document into the demo. The second step is schema creation. As I mentioned earlier, creating a schema from scratch can be quite a tedious task. So our product provides automatic schema generation to make this easier. A schema is generally composed of 4 main elements. The first is key name, which defines the name of information to extract. Second is the description that describes what information you want to extract. Third, you can choose the type of data, like the type of this key is string or number, integer, and so on. Lastly, you can also specify whether a field can have multiple values by checking the array field. Upon reviewing the generated schema, you can easily modify it according to your requirements. As you can see on the slide, there are 2 types of components. You can add key and also add table. A key simply represents a single field. When you add a key, the system will extract the corresponding information from the document. A table is a group that contains multiple keys. Think of a receipt where several items have been purchased. The receipt will include multiple items, and each item will have its own keys, such as product name, product price, and quantity, like that. A table is the structure used to represent this kind of repeated data. As you can see on the slide, you can modify the key name, description, and table title by clicking on. And you can also adjust the type of each data. As of now, our products support 4 types: string, number, integer, and boolean. As I mentioned, you can also modify array option to specify whether a field can have multiple values. When you click the Save and Extract button, the system extracts information from your document based on the defined schema and displays it as shown here. If you click on any of the extracted result, you can see where that information is located in the original document. You can also try uploading different documents, and based on the schema you defined before, the system will extract information from the new document as well. If you want to modify the schema after reviewing the extraction result, you can also back to the previous screen by clicking Edit Schema. Everything we did in the demo can also be done via the API. I assume that when you build your app during this hackathon, you will most likely be using the API. If you click the Using API with this schema button in the demo, you can see an example code snippet. Although the information extract API hasn't been made public yet, we are giving early access exclusively to participants of this hackathon. That's the end of my presentation today. I'm really looking forward to seeing the amazing RAG and agent-based applications, maybe especially about document-specific application. You will create using Upstage document parse and information extract. I hope to see a lot of creative and original ideas come out of this hackathon. Thank you for listening, and if you have any questions, feel free to ask. Thank you. Do you have any questions about document parse or information extract? So 1 minute left, and today we open the information extract demo with open public beta. So even though you don't log in, you can use directly. So please use our information extract demo, and also you can give the feedback how we can improve this product. Thank you.